Hi learners, I welcome you to the SWAYAM course on Introduction to Climate Change. Today, I will be discussing with you the basics of climate change. We all know that Earth's climate has never been static since the formation of Earth. The present day climate change is quite different from 2 points. One important point is the modern day climate change is due to human action, human activities. The second important aspect of present day climate change is the change that is happening is so fast and rapid that the potential impacts is bound to be huge, enormous and unparalleled in the history of mankind. If you look at the human activities were responsible for the present day climate change, and it has been reported widely that human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial levels. This global warming is likely to reach 1.5 degrees centigrade between 2030 and 2052 if it continues. The kind of production, the kind of energy use, if it continues, definitely it will be alarming to the existence of mankind. Ocean warming is too significant. For instance, ocean body account for more than 90% of energy accumulated between 1971 to 2010. In fact, since the beginning of industrial revolution, the ocean body has taken up a lot of carbon dioxide into it, and that has led to ocean acidification. If you look at the pH value, pH of ocean water, it has decreased by 0.1. And in fact, that signifies how much that has caused harm to the ocean body and the other organisms living in the ocean ecosystem. So ocean acidification is a very important aspect that is a consequence of global climate change. When you look at the ice masses that is in the Greenland and Antarctica, it started losing mass, because of climate change. Subsequently, if you look at the glaciers present in the terrestrial, whether it is Himalayan glaciers, it started shrinking, and that is a very important symptom of climate change. Over the period of 1901 to 2010, the global mean sea level has rose by 0.19 meters, and it is a very significant amount, and that is because of the changing dynamics in the cryosphere. And the last important symptom, or in other words a visible symptom because of climate change, is the extreme events. The extreme climatic events, whether it is a warm temperature or the heavy precipitation, that has started showing a lot of changes in the near past, and that is because of climate change, anthropogenic climate change. When I talk about the anthropogenic climate change, we call it as a modern climate change, and this modern climate change is because of two important reasons. One is the human action and the economic activities. The kind of economic activities it has increased since the Industrial Revolution, and most of the economic activities have been driven by the use of the fossil fuels, energy use, and because of these two reasons, the modern climate change is showing the rapidity. The change is so fast. And as I said, the potential impact is enormous in nature, and we need to take a lot of measures, proactive measures, to contain the increase in temperature. This anthropogenic greenhouse gas emissions, if you look at it, it has increased very rapidly. On an average, if you see the per annum, the greenhouse gas emission is 49 gigatons of carbon dioxide equivalent. And when you see the period between 1750 to 2011, the cumulative anthropogenic carbon dioxide emissions to the atmosphere were estimated to be around 2040 gigatons of carbon dioxide. See, when you look at the amount, it is 2040 gigatons of carbon dioxide equivalent, and within this amount, if you see, the 30% of the emissions, the carbon dioxide emission, has been absorbed by the ocean body, 20% by the terrestrial ecosystem, whether it's a land or it's a plant. Remaining 40% is present in the atmosphere, and that is the huge amount that we have to take into account, because we need to take the measures to sequester the carbon from the atmosphere, and a lot of proactive measures, a lot of practical mitigation measures are there that we'll see in the coming sessions. Before we discuss the climate system, it is pertinent to know the difference between weather and climate. Although the words weather and climate sound almost similar, the difference exists between weather and climate from the perspective of space and time. You have studied that weather reflects the state of atmosphere at a particular time and place. Weather is the daily or short term variation of different conditions of lower atmosphere in terms of either its temperature, pressure, wind, rainfall or any other parameter, meteorological parameter. So, weather comprises the day-to-day conditions of the atmosphere at any place. It is never static and thus cannot be generalized. On the other hand, climate is a statistical measure of state of atmosphere in terms of meteorological variables like temperature, rainfall, atmospheric pressure, humidity, etc. for a particular region for a period of more than 35 years. So, the climate can fluctuate on short time scales, producing for instance the hydrological drought, agriculture drought and over much longer time scales giving rise to glacial epochs. Coming to the aspect of climate change. This climate change can be defined as the variation in either mean state of the climate or in its variables persisting for an extended period of time, typically for decades or even for a longer period of time. It includes temperature increase, changes in precipitation pattern, sea level rise, increasing the frequencies of extreme climate events. These all and everything will be part and parcel of climate change concept. If we call global warming, we take into account global warming, it is basically the increase in the air surface temperature that is called as global warming. Further, the climate change follows a specific pattern of change in climate or its variables over a period of time. As far as the definition of climate change is concerned, United Nations Framework Convention on Climate Change has defined climate change as a change in the state of the climate that can be identified using certain statistical tests by changes in the mean and or the variability of its properties and that persists for a longer period of time. Typically, as I said, it is for the decades or even for a longer period of time. On the other hand, a related concept, that is climate variability, it refers to the sudden and discontinuous seasonal or monthly periodic changes in the climatic or its components without showing any specific trend of temporal change. This is climate variability. Both concepts go hand in hand, climate variability and climate change. Again, the United Nations Framework Convention on Climate Change has defined climate variability as the variations in the mean state and other statistics of the climate on all possible spatial and temporal scales beyond that of an individual weather events. This is about the climate variability concept. To understand the climate change and climate variability, let us consider a time series data of a meteorological parameter. For your information, series is said to be stationary when the average values for the shorter period are effectively same. And we can have every possible meteorological parameter, but the common metric is the temperature. These parameters fluctuate from observation to observation also, and this fluctuation from one observation to another about the mean is the measure of climate variability. As I said, the temperature is a popular metric as far as the meteorological parameter is concerned. For any temperature record that is stationary, the statistical parameter can be present in a kind of a bell-shaped curve. We call that as a normal distribution. In case of a Gaussian or a normal distribution, the peak represents the mean. The width of the curve is the measure of the variance. When you look at this picture, the temperature data has been plotted, and when there is a change in the temperature, when the global mean is changing, the temperature is the mean is changing, shifting towards the right, that means that temperature is increasing. So if you can see that from this particular picture, the number of days, the hot days, it is increasing. The extreme events started increasing in terms of hotness, but as far as the cold days are concerned, it is lesser. So this is a very important thing as far as the increase in the average temperature. When you look at the next picture, in this case, as I said that the bell-shaped curve, the width of the curve has enlarged, and when you say width of the curve, that bell-shaped curve has increased, it means that I am talking about the variability, I am talking about the variance, and because of the increase in the variance, you will be finding more of hot weather, more of cold weather, the externalities, or you will be finding a lot of extreme events that is taking place because of variability, because of climate variability. And when you look at the next one, in this case you will be finding both increase in the mean value and also the variability value. So when I say both the mean and the variability is increasing towards the right side, it means that you will be finding more of extreme events in terms of the hot weather. It will be more of hot weather, the number of days also will be much higher. So this is the significance of the climate change and climate variability, and what we need to take into account is that not only climate change, the variability is also very important, because the kind of extreme events that is taking place in terms of the the precipitation or the drought condition, the flood, it is increasing day by day, year after year it is increasing, and this is because of climate change. Next concept as far as the climate change is concerned, it is the concept of climate system. The United Nations Framework Convention on Climate Change defined the climate system as a totality of the atmosphere, hydrosphere, biosphere and geosphere and their interaction. This is the basic of climate change, the kind of interaction that is taking place within all the components of climate system. Let us see one by one the components and how it is important for the climate system to be dynamic, because the climate system is very complex system and it is a very dynamic in nature. The climate system is basically powered by the solar radiation. Since the Earth's surface temperature has been relatively constant over many centuries, the incoming solar radiation, that is short wave radiation, must be nearly in balance with the outgoing long wave radiation. There should be a balance between the SWR and the LWR. About half of short wave radiation is absorbed by the Earth's surface. About 30% of the short wave radiation is reflected back to the space, and 20% of short wave radiation is absorbed in the atmosphere. This is with respect to the short wave radiation. With regard to the long wave radiation, that is the radiation that is emitted from the Earth's surface, it is largely absorbed by radiatively active gases, or in other words the greenhouse gases like water vapor, carbon dioxide, methane, nitrous oxide and other related greenhouse gases. The long wave radiation is also called as terrestrial radiation, and they are long wave because of the Earth's surface temperatures. On an average it is 15 degrees centigrade, and since the Earth's surface temperature is 15 degrees centigrade, the radiation emitted by the Earth's surface is long wavelength. The downward directed component of this long wave radiation heats the lower atmosphere, and this process is popularly called as greenhouse effect. So let us see one by one the component of the climate system. The first and foremost component is the atmosphere. This component is very unique and it is most unstable. Why? Because the composition, look at the composition, it is constantly changing. Nevertheless, the dry atmosphere composed mainly of the nitrogen, N2, oxygen and argon. If you look at the volume concentration, it is not changing and it is almost constant as far as the nitrogen gas is concerned, oxygen and argon is concerned. And in fact, these three important gases never interact with whether it is the incoming solar radiation or long wave radiation. It is not interacting, and in that way it is less significant with the Earth's budget is concerned. I am talking about the energy budget is concerned. But look, there are certain group of gases, they are called as trace gases, because the quantity is very less. But the kind of contribution to the Earth's energy budget is concerned, it is tremendous, and these gases are called as greenhouse gases or radiatively active gases. We know that the radiatively active gases are carbon dioxide, methane, nitrous oxide, ozone. These all the quantity is very less. In fact, if you look at the on volume proportion, it is less than 1%, but the kind of contribution to the Earth's atmosphere or Earth's energy budget is concerned, it is immense. and these are very important for the greenhouse effect. In fact, our existence, the Earth's surface temperature is 15 degrees centigrade on an average. It is because of greenhouse effect. When you look at the gases, the water vapor, particularly, it is a very significant naturally occurring greenhouse gases, and the concentration, if you look at it, is in the order of 1%, but it is a very significant greenhouse gas, water vapor. And when you look at the water vapor and the carbon dioxide and ozone, these three important gases also absorb the short wave radiation. They absorb, in addition to the long wave radiation, they also absorb the short wave radiation. This is with regard to the greenhouse gases. The second important component is the hydrosphere. This hydrosphere is it's a component that comprises all the liquid surface and subterranean water, both fresh water, it includes the rivers, lakes, aquifers, and even the saline water of the oceans and seas, all will be part and parcel of the hydrosphere component. And of course, with the huge component, the major component is the ocean, because it covers 70% of Earth's surface is covered by the ocean body, and it's a significant contributor as far as the Earth's energy budget is concerned, because this ocean body stores, as I said, it stores and transports a large amount of energy, immense amount of energy it stores. And the second important aspect as far as the ocean body is concerned, it dissolves and stores great amount of carbon dioxide. That's a two important aspect as far as the ocean body is concerned, and that is significant because it acts as a kind of a regulator to the Earth's energy budget. As far as the circulation pattern is concerned, that's called as thermohaline circulation, because the circulation that is taking place in the ocean body, because of the temperature gradient or a salinity gradient, we call it as thermohaline circulation. And this thermohaline circulation in the ocean body is much slower than the atmospheric circulation. It's a very important point. It's a very important point to be noted, mainly due to the large thermal inertia, that's what we said, of the ocean. They dampen the vast and strong temperature changes and also functions as a regulator of the Earth's climate. That's a very significant component, and it acts as a source of natural climate variability. In particular, for a longer period of time, it's a very significant component. The third important component of climate system is the cryosphere. When you talk about the cryosphere, it includes the ice masses that is existing in the Greenland or in the Antarctic, and even the continental glaciers and the snowfields, the sea ice masses and permafrost, everything will be part and parcel of the component called cryosphere. And as far as the cryosphere is concerned, it is related with the energy budget from two or three important points. One is that it is known for the high reflectivity, the albedo value, that is high. It's very high in case of the ice masses are concerned. The second important point is it's the low thermal conductivity. The third important point, as I said, that it is the large thermal inertia, and definitely these all three are very important thing, and that signifies its role in driving the deep ocean water circulation. This is about the cryosphere. Then the fourth important component is the land, lithosphere, or in other words, the vegetation and the soils at the land surface. They are very, very important as far as the Earth's energy budget is concerned, and from the perspective of climate system interaction also, because the vegetation and soils control how energy received from the sun is returned back to the atmosphere. How it is returned back to the atmosphere, that is the most important point to be noted. Some of the energy received from the sun is returned as long wave radiation, hitting the atmosphere as the land surface warms. Some of the energy also serves to evaporate water, either in the soil or in the leaves of the plants, bringing water back into the atmosphere, and hence the hydrological cycle. The texture of the land surface, in other words, the roughness, the topography, it influences the atmosphere dynamically as winds blow over the land surface. And this is a very important point to be noted, because the wind movement is also very important for transfer of energy from one place to another. With regard to the marine and terrestrial biosphere, it's a very important component of the interaction that is taking place in the climate system. The biota influences the uptake and release of greenhouse gases, particularly the carbon dioxide. Through the photosynthetic process, both the marine and terrestrial plants store significant amount of carbon from the carbon dioxide, and thus the biosphere plays a significant role in the carbon cycle as well as in the budgets of many other gases, not only carbon dioxide, such as methane and nitrous oxide. So in the coming sessions, we will be discussing about the natural drivers of climate change, which includes the variability in the solar constant, or in other words the solar output, orbital variations, tectonic processes and volcanic eruptions. With regard to the anthropogenic drivers of climate change, we will be discussing about the atmospheric composition, changes in the land use pattern and also changes in the aerosol level. Thank you.